Hey chemistry students, welcome to your tutorial on Gay-Lussac's law, where we're going to use the equation P1 over T1 is equal to P2 over T2. So here's our example. A gas has a pressure of 0.370 atmospheres at 50 degrees Celsius. What is the pressure at standard temperature? Alright, and I already have set up where I'm going to try and figure out what variables I'm given and determine my target variable, so what I don't know yet. Alright, so a gas has a pressure of 0.370 atmospheres. Well, that's my first pressure. So 0.37 atmospheres, and it has this value at 50 degrees Celsius, but we have to remember with gas laws, when measuring gases, we go to Kelvin. So to go from Celsius to Kelvin, I add 273. So 50 degrees Celsius in Kelvin is 323 Kelvin. Now I'm asked, what is the pressure at standard temperature? So that means I don't know my pressure yet, but I have a plan. Standard temperature is 273 Kelvin. So now I am ready to plug into my equation. So 0.370 atmospheres divided by 323 Kelvin. I'm going to set that equal to my second pressure, I don't know yet, divided by my second temperature, so 273 Kelvin. Now, Lussac's law is directly proportional. So the relationship between pressure and temperature is directly proportional. So that means that if one is increased or decreased, the same thing happens with the other variable. So I'm going to hypothesize that if we decrease our temperature, that our pressure will also decrease. So now what I'm going to do is solve for my variable. So I need to undo what has been done to it. So right now it's being divided by 273 Kelvin. So I'm going to multiply by 273 Kelvin. And what I do to one side, I have to do to the other. And when I multiply on the other side, it goes on top, remember? So when I do that, these cancel out, and I'm left with just my variable. And over here, if I have a Kelvin in the numerator and in the denominator, that unit is going to cancel out. So my unit that my answer will be in will just be atmospheres. So now I'm just going to multiply 273 times 0.370 atmospheres. And I'm going to divide by 323. When I do that, my answer is 0.313 atmospheres, which does satisfy Gay-Lussac's law, where my temperature decreased and my pressure decreased as well. Alright, thank you for watching. Remember to work on your practice packet and to look at those starters and finishers. As always, if you have any questions, let me know.